We're looking at homework from section 3.3, specifically question number 8. Let's go ahead and read that question statement. Of the cartons produced by a company, 8% have a puncture and 3% have a smashed corner, and 1.3% have both a puncture and a smashed corner. So find the probability that a randomly selected carton has a puncture or a smashed corner. So again, this is an addition rule problem. Let's go ahead and review the addition rule. The addition rule says that the probability that event A or event B occurs is given by probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Of course, if they're mutually exclusive events, the formula shortens to just the probability of A plus the probability of B. So, we need to know whether or not they're mutually exclusive to know which version of this formula that we're going to use. When we ask that question, we're asking, is it possible for a box to have both a puncture and a smashed corner? And they give us a percentage that says it is. It's 1.3% of all the boxes have a puncture and a smashed corner. So because it's possible to do both at the same time, these events are not mutually exclusive. So we're using the original version that has the subtraction of the probability of A and B at the end. So for us, the probability of a puncture or smashed corner would be the probability of a puncture plus the probability of a smashed corner minus the probability of a puncture and a smashed corner. Probability of a puncture, now we're going to convert our percentages into decimals. Probability of a puncture is 0.08. The probability of a smashed corner is 0.03. And the probability of a puncture and a smashed corner that has to be subtracted is 0.013. So when we add these together and subtract, we get 0.097. And that's your answer.